Hello everyone and welcome back to Mathematics with Usman. This is second video in my series on the topic absolute value function, and today we are going to see the graphs of absolute value functions. Students, I told you there are different objectives that we have to attain in this particular absolute value function we have to attain. Number one, understand the meaning of modulus of x, sketch the graph of y is equals to modulus of x plus b, and use a equals to modulus of b can implies a square equals to b square. However, students, in the second objective, we deal with the inequalities. When you are given with the inequality, modulus of x minus a is less than b. This is equivalent to say x is greater than a minus b and x is less than a plus b when we are solving the equations and the inequalities. Students, let's begin with the graphs of absolute function. And the first graph that we are going to see is y is equals to absolute value of x. Students, referring to the previous tutorial, I told you there are two pieces of this function. We can have the value of x that is greater than 0 or equals to 0, and we can have the value of x that is less than or equals to 0. We can write it like this. See that when x is greater than or equals to 0, we will leave the x as it is. If we have the positive value of x, let's say it's 4, we will leave it as 4. However, students, if the value of x is less than 0, for example, we are having minus 3, we won't write it minus 3, however, we have to take the positive value of it by multiplying the number x with the negative number. So what we are going to have is, if x is greater than or equals to 0, leave it as x. And when x is less than 0 means x is negative, then you have to multiply the negative sign with it. Let us consider the Cartesian plane. X is the horizontal axis and y is the vertical axis. Now we want to draw the graph of this. Students, just simply consider y is equals to x and draw the graph of it. If we take the unit 1, what will be the value of y? It is also 1. So we are having this point, 1. If we are having the x value of x equals to 2, the value of y is 2. If x is 3, value of y is 3. If x is 4, the value of y is 4, and so on the negative hand side. So what is the graph of y is equals to x only? It is this one for the positive values of x and this one for the negative values of x. However, students, you can see that when we are having the value of x that it is less than 0, what we are going to do, we are not going to take the negative number. Instead, we have to take the positive value of that x. So when I replace x with negative 1, the answer is negative 1, but we have to take the positive value of it. So what happens? I will go in the upward direction. So this is the reflection of this number in the x-axis, and I'm going to get this value. Similarly, if I take all the numbers like this, it is 2 units down, so I have to take units up. This is 3 units down in the x-axis. I have to take the reflection of it in the x direction, which is this number. This number is 4 units in the x direction in the downward direction. If I take the image of it in the x direction, I am going to get this number. So students, the graph of the second portion of the graph when x is less than 0 is going to be the negative x, which is the reflection of this graph in the x direction. So I'm going to get this graph. Here it is. So students, you can see clearly over here, this modulus function or the absolute function graph is a bouncy graph. It bounces at the origin. To understand this concept more clearly, students, let us consider the simplest of the example. In example number 1, we have to draw the graph of y is equals to modulus of x minus 1. Let us first consider the piecewise function for this graph y is equals to x minus 1 and the absolute values. If we consider the absolute values of x minus 1, what we are going to have? We are going to have this piecewise function. When the value of x is greater than or equals to 1, we have to leave the modulus value as it is, which is x minus 1 in our case. However, if the value of x is less than 1, then we have to multiply the negative number with the original values of x minus 1. So I'm going to get minus in the bracket x minus 1. To draw the graph, let us consider the Cartesian plane with x as the horizontal direction and y in the vertical direction. Students, you can see clearly over here, our graph is going to bounce at 1. So let us take 1 over here. Whenever I will take the values of x greater than 1, I will use this graph, which is x minus 1. So at 2, the value of y will be equals to 1. At 3, the value of y will be equals to 2, and so on and so forth. So this is my graph for x minus 1 function when it is positive. However, students, if I take the value of x that is less than 1, I have to use this piece of the graph, which is minus times x minus 1. So students, the graph for this is going to be the reflection in the x direction, but always the positive values. So I am going to get this graph for minus x minus 1. Let us now extend this idea to the next problem. What we are going to have, if I give you to solve an equation graphically, which is x minus 1 in the mod, but this is equals to sum 3. Students, you can see clearly over here, we are given with the two functions. One is x minus 1, which is already drawn over here, and the right hand side of the equality, which is equals to 3. So I have to draw the graph of y equals to x minus 1, which I have already drawn for you, and the second graph, y is equals to 3, which is a constant number. So this is going to be a horizontal line parallel to x-axis like this. Y is equals to 3. Now students, since these two graphs are equal, it is given in the question, so we have to identify the 2 points where these graphs are equal. I can see clearly this is the point and this is the point where 2 of the graphs are having the equal values. So note down these 2 values of x equals to minus 2 and x equals to 4. Hence, the solution, graphical solution of this equation is going to be x equals to 2 minus 2 and x is equals to 4. Let us now further extend this. If instead of equality, if I introduce the inequality over here and write the question like this. Also solve x minus 1, but this time replace the equality with the inequality where modulus of x minus 1 is less than or equals to 3. Student, now in the graph you have to examine the graph of x minus 1, which is this graph, where it is lying below your graph of y is equals to 3. And it is obvious from the graph that from here onwards to the right, the values of this graph are less than this. See, if I consider this point is less than y is equals to 3. If I consider this point, it is less than 3. If I consider this point, it is less than 3. However, if I move to the right of 4, now y is equals to 3 is lesser than the graph of modulus of x minus 1. So I have to identify the numbers. So numbers starting from minus 2 and ending at x equals to 4 are the values of x, or the range of the x that we can have in which this graph x minus 1 is less than or equals to 3. So I can write this inequality or this range like this. X must be greater than or equals to minus 2 and x must be less than or equals to 4. Students, algebraically we can have the same solution that we have graphically. Let us consider algebraic sum of these two, algebraic solution of these two graphs. Students, you can clearly see that this portion of the graph is x minus 1 and this equation is intersecting it at this point, and this is only one point. So I can write the point of their intersection as x minus 1 is equals to 3 over here. So I can write it like this, which gives us x is equals to 4. Similarly, on the left hand side, this is the portion where y is equals to 3 intersects with the negative portion of x minus 1. So what I can do over here, I can compare x minus 1 with the negative sign, that must be equals to 3. So when we solve it, we will get the same answer as we got in the methods of graphical solutions. And this brings us to the end of today's tutorial. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial and have yourself a productive day.